Hello, everyone. Happy Wednesday, and welcome to another edition of Breakfast by the Bay and my first ever YouTube Live. I'm so excited to be with you all today. My name is Jess, and I'm joined behind the scenes by Adam, who's going to be our technical wizard today. So you might see him from time to time. And we are coming to you live from Save the Bay's Exploration Center and Aquarium right here in Newport, Rhode Island. So I'm going to be doing a ton of talking to you all today, but I want to hear from you guys. I would love to hear what school you guys are coming from, and we already have one tuned in. So Miss Quart's class is here from Pell Elementary. Welcome to our Breakfast by the Bay. We're so happy to have you. Also, if you have any questions or fun facts you want to share, I would love to see those in the comments, and I will answer them at the end of the video to my best of my ability. If you like what we're doing here, please make sure to subscribe to this YouTube channel. That way, every single Wednesday at 10 a.m., you can see one of our educators go live on YouTube and also share some amazing lessons and things of that nature. So I've been enjoying these videos so far, and I can't wait to get into today's topic. And today we are going to be learning about the really fascinating intersection between technology and nature. Sounds crazy, right? But it's really fascinating. So this is something called biomimicry. And whenever I hear a big word, I like to try to break it down. So on this piece of paper, I broke down that word. So we broke down into bio and we broke it down into mimicry. So that root word bio means life. So I've heard that when I've heard of biology, the study of life. Marine biology is the study of sea life and things like that. So we got that first part. We're already rocking and rolling. And then that second part, mimicry. It kind of reminds me of a mime. And what do mimes do best? They copy or they imitate. So if we were to put that all together today, it's the copying or imitating of life. Very cool. And that's exactly what biomimicry is. So biomimicry was created by human beings as a way to help us with some of our really complex design issues. So this can be things like infrastructure. So those are like buildings of houses and communities and things like that. It can be technology. It can be things as wild as clothing and even governmental policies. So all of this helps us to better incorporate and mesh with Earth because all of this is inspired by nature. And when things are inspired by nature, they tend to be more sustainable. So this helps humans incorporate with the Earth and stay on the Earth much longer. So my question for you guys is, why would we use nature to inspire things like technology, which are man-made? And to come up with that answer, we're going to look back on how long life has been on Earth. So the Earth is really, really old. It's about 4.5 billion years. Crazy, right? And life on Earth has been here for about 3.8 million years. But humans, Homo sapiens, the modern day human, has only been around for about 200,000 years. And I know I threw a bunch of numbers at you, so I kind of want to break that down and see how humans have been around as much as life. So if we were to compare all of life on Earth, that 3.8 million years, into 24 hours in a day, right? So that whole time period of life is only a day. Not too bad, very manageable. But to see how long humans have been around in that, they've only been around in that 24 hours for about 1 second. So not very long at all. So there are things like bacteria, plants, and animals that have been able to survive for so long. And they did it not just because they're really amazing and awesome, but they did it because they've learned to adapt to Earth and its changing nature. So we as human beings that haven't been around as long can really look to them to help us be more sustainable and help us with the future. So now what we're going to do is we are going to all be biomimicry scientists today. And the first thing a biomimicry scientist does is ask a really great question. So my first question for you all, and it pertains to a lot of what's going on today, is how do we make something that's antibacterial or can repel that bacteria in the atmosphere and in our kitchens in our world? So we have created stuff as humans, right? We use cleaning solutions and things like that. And it does a great job at killing off that bacteria. So, but this contains a ton of chemicals, and it also is housed in this plastic bottle right here. So it might not be super sustainable. So let's think, is there something in nature that has actually mastered how to do this? And you know what? There actually is. So there is an animal that is actually found right here in Narragansett Bay that has a property or adaptation on its body to help it repel any living organisms, including bacteria. So I'm going to reach over and grab this animal for you all to see. So he's kind of in a funny position. Well, there he goes. He's swimming around. So this is our chain link cat shark. You might have recognized him from Mr. Jeff's really awesome video on sharks a couple weeks ago. If you haven't watched it, definitely recommend to check it out. So this guy normally sleeps right at the bottom of this container, but since I picked him up, I kind of stirred around his home a little bit. He's moving around, but normally these guys lay flat on the bottom of the bay, but yet nothing grows all over their body. And to put that in perspective, anything in the marine world that typically is very slow moving normally is covered with living animals, bacteria, and things of that nature. But this animal, one of our oldest animals in the world, has actually been able to do that. And so in order to show you that, I didn't bring a powerful microscope today, so I actually have a picture zoomed in on the shark's skin. So this is what keeps them really safe from all that bacteria. So this is zoomed in really close. And they have something on their skin called dermal denticles, which means skin teeth. And looking at this, you can tell that is definitely skin teeth. So because of all these deep ridges and grooves, it is not a very happy place for bacteria or other animals to live. So they never grow on the shark's skin. So what a very smart company did is they wanted to learn how could they take this pattern and create something that we could use in maybe hospitals and maybe doctor's office to create a surface that doesn't grow bacteria. So looking at this picture up here, these are more dermal denticles. These are the dermal denticles from a Galapagos shark, so not native to our bay, but close cousin. And this is the material they made. And remember, this is really zoomed in. So this pattern alone, with no chemicals, no nothing, is able to repel bacteria. So that means we don't have to use any more of this cleaner, right? No more chemicals and no more plastic. So a really sustainable way to help manage bacteria. Another really cool thing about these dermal denticles is they actually help our sharks move quicker and faster through the water. So a company that designs Olympic swimsuits actually used it to design a swimsuit for the 2008 Olympics. So if anybody's big fans, we have Michael Phelps in this picture. And this swimsuit actually helped the swimmers swim just a little bit faster. And in a sport where a tenth of a second could mean you're getting the gold medal or you're coming in 12th place, this really helped. And it was so efficient that they actually banned this swimsuit after that Olympics. So pretty wild. And this all just came from the skin of a shark. Fascinating. So my next question for you is, how do we turn towards nature to design a safer and more efficient car? So this one really perplexed me. I was thinking about it, and when I think of the shape of a car, I don't really think of much in the animal kingdom or in the plant kingdom that might be a shape of a car, right? I think of something like a rock, and that doesn't seem very efficient. It doesn't seem like it moves around and goes from place to place. But scientists are so smart yet again, and they actually looked to this fish. This is a yellow box fish. And so we actually have some close cousins of these guys that come into our bay. They're in the boxfish family, and this guy is called a smooth trunkfish. And you can just see that very peculiar shape that they have. So the very interesting thing about these animals is because of the shape of their body, they're actually very efficient swimmers. So they might not be the fastest, but they have this beautiful shape which allows them to stay very stable in the water. They're able to flow water around them so they don't flip over, because they do look like they can flip over very easily. And they have these really horrible little fins that don't help them swim very fast, but the shape of their body is very hydrodynamic, so they do move relatively fast for how much energy they're exerting. Pretty crazy, right? So what a company decided to do, Mercedes-Benz, they decided to utilize the shape to make a really efficient and really safe car. So they created the Bionic car, which is this guy right here. So if you're in the business of looking for a super beautiful luxury car, this might not be the one. It doesn't look like a nice Lamborghini or anything like that. But this car is really stable. It's not going to flip over on the road, so it's a really safe car. And it's actually super efficient. So this car can go from about 0 to 60 in under 8 seconds, and all while getting about 70 miles per gallon. So to put that in perspective, the average car on the road gets about 25 miles per gallon. So this car alone is saving tons of those fossil fuels on our roads each and every day. So super, super amazing. And all inspired by this little clunky fish right here. I can't believe it. So my next question for you all is, how do we take something that's already sustainable, like renewable energy, where we're able to harvest wind power, water power, sun power, and turn that into renewable energy? How do we make that more efficient? And so what we're going to be looking at today is the wind turbines. So this is a beautiful picture of the wind turbines off the coast of Block Island. If you haven't seen them, highly recommend it. They're very beautiful. And these actually power most of Block Island, and sometimes on a windy enough day, it will actually power some of mainland Rhode Island too. But how do we make these more efficient? How do we get them to power more of Rhode Island? So what scientists did is, these are behemoths, they're huge. So they wanted to turn to a very giant but agile creature. So they looked at the humpback whale. So this humpback whale is very agile for its size. It's several thousand pounds. And if I was several thousand pounds, I wouldn't be able to move as gracefully as a humpback whale. So they're able to leap out of the water. They're able to cruise pretty fast for their size. So scientists wanted to look at this animal and see what it was about that animal that made it so streamlined, so efficient. And so they actually looked right here at these pectoral fins. So if we look close, it kind of looks like the exact same shape as a wind turbine, but there's something different. So I'm going to flip over to this next picture so you guys can see. But what they did is, these tubercles, or little bumps on the humpback whale's fins, actually help it reduce drag. And that's really important if you're dealing with anything with wind or water. You don't want to have to put in a ton of extra energy to get a job done. So these tubercles help reduce the drag. So we can see here in these blades, there's little notches carved out. So those notches make our wind turbines about 20% more efficient. So these wind turbines, if we switched over, they would actually be able to power not only Block Island, but maybe even all of mainland Rhode Island, which would be so exciting. So there's a lot of things to look forward to once you combine technology and once you combine nature. So I have a piece of homework for you all. So we learned how to be a biomimicry scientist. We asked some great questions, and we turned to nature to see if there was any answers. And we found out, yeah, there were. So when you guys, after this video, or when you get home, whenever you would like to do it, I want you guys to ask a question. Maybe this is something you can fix in your household. Maybe this is something you can fix in your community. And then go for a walk. Look and see how nature can maybe help you with all of these things. So that's just really great. Beautiful. And then if you're really, really interested in this topic, there's a link below to take you to the Biomimicry Foundation, and they do a ton of great work. They're constantly asking these questions and solving these problems. So if you want to get actively involved, feel free to check that out. It's a great resource. I'm just going to take a look and see if we have any questions. Oh my goodness, look at all of these people from Pell. I'm so excited. We miss you guys so much here at the Exploration Center, and thank you so much for tuning in. I just want to thank you guys so much for joining us today. I had a blast, and I hope you guys liked learning about biomimicry and all that it can do to help us create a more sustainable future for humans as a whole. If you like what we're doing, please make sure to subscribe to our YouTube channel, give this a like, and we're going to be here every single Wednesday at 10 a.m. So feel free to join and tune in then. But if not, have a great rest of your day, and we look forward to seeing you next week. Bye, guys.